Hello everyone, my name is Adrian. I'm from Guatemala. I'm currently a GDE for Android, IoT, and Firebase. I'm going to be one of your tour guides for the next 20 minutes. And I'm an Android developer who coded an iOS demo for this talk.
And hello, my name is Cecilia Castillo. I am a mobile engineer at Zoom, and I'm going to be talking to you about I worked on the iOS part of this experiment, and let's go and talk about Kotlin and Swift. So a little bit of a disclaimer, even though we're going to talk about how learning a different language helps you understand better the other platform, I know that each team has its own challenges and constraints, so there's no one solution fits all. So if you ever try to do this sort of thing, you have to be aware that you have to experiment until you get to the right place for your tool.
So there's no silver bullet, although we're advocating for becoming bilingual, learning a little bit of Swift. This is an Android conference. It's important to keep in mind that we're going to show a little bit of our results during this experiment, but there's no silver bullet.
So this is a little bit of the agenda. We're going to share a little bit about our motivation, what got us to this talk. We're going to talk also a little bit about the experiment that we developed to be able to share our findings, our conclusions, and our learnings about this journey, about learning Kotlin and Swift at the same time. So first I'm going to talk a little bit about my experience. I work right now at a company called Zoom. And there I was lucky enough to be able to give it a chance to work on both platforms, Android and iOS. I came from a whole Android background. And when transitioning to this iOS part, it was really difficult at first because it required kind of like a mind shift. There were some concepts that I was not usually aware, like protocol-oriented programming, functional programming, then map, filter, reduce. There are a lot of things that were kind of like confusing for me. And also at first, when I started, there's one person that always kept telling me that at the end, both platforms shared kind of like the same business logic and the same implementation. And there's only little details that differ from one platform to another one. But since I came from the Android background and I didn't have iOS background, it was pretty difficult for me to see that, and I only saw differences. But after a while, I was able to see that at the end, both platforms are the same.
In my case, the motivation it's a little bit different. A while ago, I used to be the co-founder of a development studio. I was playing the entrepreneurial game. We started as a product-oriented company. It didn't work. Eventually, we switched to casual Facebook video games. Eventually, we transitioned to mobile development. This was a while ago. It was 2010, so we were doing Android, iOS, and BlackBerry. So when you are a co-founder, some days you are with a client, other days you are coding, other days you are preparing coffee for the whole team. And in my experience, keep in mind, this was 2010, and also in Guatemala, so our market is quite sensitive to the price. Our clients were asking for an iOS-first approach, but they wanted the Android app like right away without a huge investment. So because of that and the constraints, we were dealing with cross-platform approaches at that time. I'm not entirely proud about this, but we used Apache Cordova. At that time, it was PhoneGap. It's not the best solution, but it was something that worked for us at that time. After that, I learned the hard way. I've been advocating for native for a real long time. But as I was saying, both on the business side and on the technical side, we do want some cross-platform approach, or at least something that eases the process of having the same app on both platforms. So when we were discussing about this, we were looking forward to build something that was simple enough for us to share in a short lightning talk, but also complex enough to show the similarities and differences of both languages. We're focusing mostly on languages, not exactly on platforms. So as both of us, like several things, we're discussing on which experiment would be possible for us to build. And we're building something from scratch, either if it's a business app or some passion project. It's like playing Jenga, but not like this. It's like more like this, when everything falls apart when you took the wrong decision. So to begin with, we decided to go with dogs. Both of us like dogs. Those are my puppies. This is Toby, a golden retriever, and Chesito, the pug. And we went with a dog API. So this small project that we built for the talk, it's a really simple app where you can guess the breed of a dog. Here's the Android app and here's the iOS app. As you can see, we are not graphic designers. So here you need to get the Samoyed, it's on the bottom right corner. Here you need to get the shipper key. I have no idea which one of those is a shipper key. But anyway, this is the experiment. We are building this app, and of course, we need an architectural approach.
So when trying to see what approach we took in order to experiment with those two platforms, we tried to see the different angles that we could approach it. So we could see it in terms of the platform. So you have activities, fragments, controllers. You can look at it also in terms of the architecture. So you use MVP, MVVM, Viper, I don't know, whatever architectural approach you use. Or we could also look at it in terms of the language, in terms of the similarities of the language. And we decided to go through this approach. First, we decided that the upper layer, regarding to the UI, we were going to keep it specific to each platform. So for iOS, we are going to use UID controllers and just how we usually do the UI in iOS. And for Android, we are going to use fragments and activities and layouts as we usually do. For the lower layers, that's the remote service and the data service. At first, we decided that we were also going to keep a specific per platform, so we could leverage using the different libraries that we already have there, like Alamofire or Retrofit. And we're going to focus to have a shared approach in the middle layers, whatever architecture we decided to use there.
As Ceci is explaining, we focus on this business logic right here, and we decided to use the common libraries. So locally, we didn't end up inventing a new MVVM library. We chose our own flavor of clean architecture and MVVM for the UI part. So the local data service is shared preferences for Android and user defaults for iOS. The remote service is using Retrofit and Alamofire. Then on the stack, we have another layer for the repository. We don't have interactors or use cases, mostly because it's quite simple, so we decided it wasn't worth it. And for the view model and the UI interaction, we have light data for Android and manual binding for iOS. As Ceci was saying, as we move to the top of the stack, it's more platform specific, but on the bottom, we tried an approach that shows the similarities between the two platforms.
By doing this experiment, keep in mind that Adrian tried to do the iOS part and I tried to do the Android part. It was kind of like my first Kotlin app that I was doing. We find similarities. For example, in terms of variables, you have the let and val for immutable variables, and you have the var in both platforms to have the mutable variables. For control flow, you have pretty similar things. You have the if, else, the while, the switch. For collections, you also have a lot of similar operators like map, filter, reduce. And this is one example of hierarchical functions and collections. As you can see in both methods, you're having a collection, an array, and in the upper one, you have the flat map to remove the nulls, and then you join by a separator that's a space. And on the lower part, you have the Kotlin part that you also are filtering by null. The name of the method is different, but as you can see, you can understand both methods. This is another example of the similarities. You have the as operator that you use in order to determine, to cast one object to another one, to a specific type. And you also have the is to determine if the one object is of a specific type. Another example of something that I found it really interesting is the generics. Generics is not something new. It has been widely used since 1970s. It has been used by languages like Pascal, Ada, C++, Java, so it's really not something new. But it's really amazing the power of generics. It's really important. A lot of the standard library is built on top of generics. And the idea of this is it's to have code that's shared, that it's reusable. This doesn't mean that you need to extract it to a method and then that way you are able to reduce the amount of time to repeat the code, but it's to have code that's independent of the type. So it's implementation that's decoupled from the type, exactly. One example that we use a lot is on the UI. So this is an example where in iOS you would repeat this kind of code over and over in all of the view controllers to just register table views cells. And as you can see on the lower layer, by extracting it to an extension and having generic code, then it's just one line.
There are many other similarities, like functional programming tools, like map in this case. We're getting the docs from an API and grabbing the breed from the URL, so that's why we need to modify things on the fly using map. And as you can see, the code is quite similar. Side note here, we implemented this having in mind, or keeping in mind that we wanted to look really similar, but there are many ways of implementation. So this is not like a universal solution, but it's possible to write the code almost using the same keywords. The difference in syntax is really small. This is another example. In this case, we're building the player object, the model representation. And again, we're using map for grabbing the data from the dictionary, the shared preferences, or the user defaults in iOS. In both cases, we wrote this code deliberately trying to be almost the same for both languages. And as we move forward in the experiment, we noticed that not only the similarities were important, but also there were differences that are considerable. So we're going to cover some of those differences right now.
So one of the first things that we notice is the use of ENUMS. ENUMS in Kotlin are really similar to the ones used in Java, so they don't have like a lot of extra things that you could do with them. On Swift, I was really used to have a good power using ENUMS because you can have associated values and you can have computer properties and methods and you could do a lot of things. We use it a lot in terms of like using it for network states, network errors, also network states. So when I tried to do this thing on Android, I talked to Adrian to see if he would suggest me something that I could use that was similar to the ENUMS in Swift. And he mentioned me that you could use kind of like seal classes. Seal classes are an extension of ENUMS, but they have the power to maintain state. So that's something really similar to the ENUMS in Swift. And that's one of the things that I really loved about it. One thing that you could also have are subclasses of seal classes, but they need to be defined on the same file. And another characteristic of the seal classes is that you could also have getters or setters depending on the val or var that you define on the states there.
And we have many other differences regarding mostly data representation in this case. In Swift, we have STRUCTS, and it's related to the inheritance from Objective-C and C. With STRUCTS, you can decide if you want to pass anything, the data, as reference or value. And this is something that can become quite interesting or can even become a source of bugs if you don't know exactly how the language is handling the data. In Kotlin, we only have a pass by reference. In Swift, we are able to decide if we want to pass something as reference or as value. And with structs, in this case, we're representing the dog. The symbol in Kotlin will be data classes. The syntax is a little bit less verbose, but although we can represent the same object using both approaches, in Swift we have a little bit more flexibility of deciding if we want to pass something by reference or by value. Also, in Kotlin we don't have tuples to represent more than one value at the same time, like a row in a relational database, but we can use data classes to get to the same result.
So protocols. Protocols, it's something really amazing and something I love in iOS. Protocols is a complete type, so you're able to pass it as a parameter on a function, or you're able to use it as a return of a function also. And it's also great for unit testing because you're able to mock things just using the protocols. One characteristic of the protocols is that they usually don't have implementation, but by using the extension, you can have a default implementation, and every object that conforms to this protocol will have that default implementation. When I started using protocols in iOS, it was a little bit confusing for me because I didn't know how to do polymorphism and how to do composition over inheritance using that. But after I understood it, it made a lot of sense. Something that I saw in Android by using classes and subclasses is that sometimes my subclasses had functionality that I really didn't need because the parent class had that functionality. So by using protocols, I was able to have more concise things of what my objects have as implementation.
It's interesting because sometimes language features force you to understand some concept that has been around for a while. Extension functions work with protocols really close by, and although it's also available in Kotlin, I would say that it's implemented to work in a different way. We have interfaces in Kotlin, we have extension functions, but you're not forced to use both in any languages, but in Swift, it makes more sense to use together the implementation of protocols and extensions. And also extensions have been around for a while for iOS developers. When I started learning Kotlin, I was amazed by this, and extension is one of my favorite features about Kotlin. So protocols are not available in Kotlin, but we can achieve almost the same using interfaces once we understand the concepts behind those. In Kotlin, we do have coroutines that are not available in Swift. And I have mixed feelings with coroutines because I really like them. I don't like RxJava that much, and I think using coroutines do a lot of the heavy lifting of dealing with asynchronous coding. How many of you are using coroutines in your code? Yeah, a lot. If you're not using coroutines, give it a test drive. I think it's an interesting feature. You can write synchronous code that do asynchronous tasks, and basically, the language is doing all the heavy lifting for you. There are many other features that are more platform-oriented for Android. I'm going to mention just one, Coin. I think it's a really simple way to implement DI. I'm in the middle of a Twitter hiatus, but before that, I noticed that in the Android community was a lot of discussion regarding dependency injection frameworks. You can choose whatever you want, but if you have worked with Dagger, contrasting Dagger, comparing Dagger with Coin, makes like a huge difference. I think Coin is also worth exploring, and it's not exactly something about the language, but an external framework that simplifies a lot of things. So wrapping up, experiments are fun. We had a lot of fun doing this, and 10 years after, I've been doing mobile for around 10 years. Cross-platform is still a challenge, but it's getting easier. I wouldn't say that we're going to get to a universal language yet, but becoming bilingual allows us to have this broader perspective. It's like learning another language, to speak another language, and allows us to see many more details.
So, as I said at the beginning, becoming bilingual requires some commitment from the team, and each team will have its own challenges and constraints. But in order to be able to move from one platform to the other one without having a major context switch, of course, we need to have some trade-offs. For example, maybe the code style would need to be defined in a pretty similar way. I know there's some people who prefer some specific things on Android and some specific things for iOS. But we need to make trade-offs. And also in terms of the architecture, if you have a similar architecture in both Android and iOS, then it's easier to move one developer from one place to another one whenever you need it. Because sometimes we are slacking off in one platform and it's like, we need to get this done and there's no one else to help the other team. So it becomes easier to move from one team to another one. This doesn't mean that we do not require platform experts. Of course, we always need persons who have a lot of depth in knowledge in one platform, for example, Android. But having a bilingual team allows you to have a pool and reassign as needed by the projects that you have.
And of course, becoming bilingual kernels implementation bugs. If you are already working with Kotlin, give a try to Swift. It's not that hard. I think becoming bilingual, it's important, and it's easier than dealing with other different approaches to cross platforms. Transpilers might be an approach that I wouldn't recommend. If you really like the two languages, learn the specific features of both. If you want to do some cross-platform work, explore Flutter or Kotlin Native. Both are really at early stages, but reaching maturity really, really fast, and with a strong community around them. And would you like to add anything else?
No, maybe since I was originally an Android developer and now I work more on iOS, I have seen a lot of benefit on knowing both. It's easier to detect bugs, to see what might be failing whenever there's a bug in Android and that in iOS is working. So I think it's very, very useful to learn both languages and have knowledge in both.
So, go ahead and have fun. Thank you very much.